My name is Paul Herzog. As she said, I'm manager at SPR Consulting for our testing practice. Thank you for setting the bar so high by saying it was very well received. I hope everybody gets a lot out of it this time as well. So we're talking today about agile testing and simplicity and how do we do the right things when we're testing. And we'll start by talking about my inspiration for this topic. This nondescript looking gentleman is named Matt Paxton. If anybody watches the show Hoarders, he is my guy. He is an extreme cleaning specialist. My favorite part about the show isn't the family dysfunction or the grossness or any of that kind of stuff. It's people who have collected thousands of items over the years, don't know what to do with it, but they keep trying to jam more stuff into this confined space that they live in, and then don't understand it when Matt walks in and says, you have to get rid of 1,900 of your 2,000 stuffed animals because you don't have room for them. In a similar vein, we're bounded when we do projects not by space but by time. We can only do the things that time allows us to do, and the things that we don't have time to do, we have to figure out a way to get rid of. So we'll take a step back and we'll talk about Agile for a minute, and we'll ask the question about why do businesses adopt Agile methodologies. Some people may think it's about being more responsive to customer change, and they heard that Agile is all about being able to handle changes, or that you're making projects easier to manage, or that you're doing more things with fewer people. In reality, people change software methodologies to Agile because they want to develop products faster. Really, every business decision that anybody makes is always about going faster. They call it efficient, maybe. Try to be more efficient with your projects because, faster means that you just don't care about quality and that you're going to be sloppy with it. But in reality, it's all about compressing schedules. So you are doing more in less time. For people who haven't worked on Agile projects before, Agile means a lot of things to a lot of different people, but it's primarily just different methods for doing project managements for software projects. A lot of its concepts come from lean or just-in-time manufacturing, where you're not trying to handle the entirety of a project all at one time. You have individual groups focusing on one thing at one time, or individuals within the group focusing on one thing at one time. An Agile team is small and, more importantly, self-sufficient. It takes its direction from itself rather than being told what to do by different managers on different teams. The Agile Manifesto is something that was developed around 4 values, where they say that we value processes and tools, we just value individuals and interactions more. We value having working software over a full set of documentation. We value having customer collaboration over contracts, and we value responding to change over following the plan. Underlying those 4 main things in the manifesto are 12 principles or values behind the 4 values, 12 principles. My favorite is principle number 10, which says that simplicity, the art of maximizing work not done, is essential to the project. One of the other things that happens with an Agile is that there's very simple definitions of what everybody's role on the team is. There's a Scrum Master, which is sort of the project manager. There's a product owner, which acts as the guiding force behind what the product has to be. And then everybody else is just a team member, whether that's development, whether that's test, whether that's design, whether that's build deployment. So as testers, we don't have a defined role on the team. So to provide value, we have to look for simplicity in every aspect of our job. What you do as a tester needs to be analyzed. Do you do less? Do you change what you're doing? Can you get away with not doing things at all? So what we have to do is focus on what's there at each point. As a project starts at inception, what I'll call sprint 0. What I'll call sprint 1, which is the first planning phase, and then every sprint after that, and then as part of the sprint retrospectives. At each part of this, as a tester, you know what your job is, and you know what people around you know or need to know about what you're doing. Everything else beyond those two things has to be questioned repeatedly. So at the inception of a project, at Sprint Zero, stakeholders create an initial backlog of user stories. These are the requirements for what they think the product has to be. At this point, a tester has to be asking questions of the user stories and of the acceptance criteria. Is this clear? Is it complete? And is it, as written, difficult to test? Years and years ago, I worked in telecommunications, and they always talked about 5 nines reliability, that the system had to be up 99.999% of the time. And I hated it. It's the worst requirements in the world, because what does that mean? If I do the math and it says, well, this is 3 minutes a year, can it be 3 minutes in a row? Does it mean that it can be 30 seconds out of every month that the system can be down? Does it mean that if it's up for 6 years in a row and then it's down for half an hour, is that good enough? We don't know. It's a bad requirement. But as testers, those are the sorts of things we need to be asking about. How would I test this to make sure that it's going to work? We probably want to plan out a test repository at this time to say how your tests are organized, named, and defined. What tool are you going to use? What environments do you have? All that kind of stuff. You want to propose improvements from the previous projects you have. If this team has worked on other things in the past, if this is release 4 of an existing project that's already had release 1, 2, 3, what can you change to be different? In addition, the last thing, we'll talk more about this in a little while, is using the idea of what's called the GQM model, or goals, questions, and metrics, to identify what metrics or what information is most important to communicate about this project. People are going to want to know about the progress that you're making and the issues that you're seeing. You have to identify up front to them how you are going to tell them, whether it's a real-time dashboard that comes out of a testing tool or some other form of a status report or something like that. But don't wait until somebody starts asking the questions before figuring out how to answer them. So if we look at a number of legacy deliverables that people have all the time, people work on documents, people prepare test documents, but they do, and maybe a lot of times people don't think about why they do them. How many people, I can't really ask the question, but I'll try to ask it in the form of a question anyway without being able to see everyone raise their hand, and say, how many people have ever written a test plan and then it gets reviewed and maybe just stuck in a drawer and then nobody ever uses it again? If people aren't reading and gathering value out of the document that you work on as a test plan, and people don't need it to do their job, maybe consider not doing it. If you don't have a standalone test repository, going through the whole idea of figuring out how you're going to organize your test cases, maybe don't do it. Test review meetings. I've been in a lot of companies and a lot of regulated environments where they have these requirements that say that everybody has to review test cases. So you get a bunch of people in a room and you read through it one by one and you show stuff on a monitor. And you have this formal process that doesn't generate a lot of value for the time when it comes to feedback. Doing a traceability matrix between requirements and user stories and the tests may be something that's built into the tool or is available to be built into a tool that you are selecting, and if so, you need to alter your process to make sure that you're not creating a manual document that can be generated automatically. As your project completes, you're going to perhaps have a test result and these defect metrics that you're gathering that you may not care about. If people aren't going to read the test results and use that information in some way, and if people aren't going to look at the metrics that you keep about defects to drive process improvements, then don't do it. If your team isn't using these things, stop wasting your time working on them. You have better things to do. By the way, all of these deliverables and all these documents that I just disparaged, they can be really valuable to you. Agile doesn't mean that you don't have to have documentation. Depending on what industry you're in, you may very definitely need traditional documents, or your project may be organized in such a way that other people in your company are adding value. About 10 years ago, one of the first things I ever went to about Agile was the seminar that was given by the CTO of this small internet startup company. And he was a huge evangelist about the code is the truth, and you don't need to have documentation, and you don't need to have process, and Agile is all about change management, and just get in there and start writing stuff and put your builds out, and people will figure out if there's problems, and it was all very off the cuff. Near the end of the presentation in the Q&A session, a man stood up and he said, I'm from a company called Medtronic, and we make pacemakers, and every single thing that you said doesn't work in my world. I need to have documents for the FDA. I need to have reviews. I need to be able to prove to somebody that we tested every condition of this device before we put it in somebody's chest, because if it doesn't work, it'll kill them. So there's value in having documentation if that's the industry that you're in and the product that you work on. But that said, all these documents are project overhead. They are time spent doing things that you could be doing other things. Project documents may also be necessary if you are working on a project that you may not see to its completion. If you are on the initial sprint team that is going to be doing release 1, and then you are going to be handing all this documentation or this product off to another team that's going to be maintaining it in the future, it's probably really important for you to write down some of these design decisions and test cases and test results and document the things that you did, so that this group isn't stuck asking the same questions and going through some of the same decision points that you had to go through. You're doing them a favor, and it's worth investing your time to do it, but understand the value in doing it. When you're in GQM, for those who haven't worked through this technique before, the idea is to say, understand who the people are that need documentation from you, and understand what their goals are. And those goals have 4 components to it. A purpose, an issue, the object of that goal or that process, and the viewpoint from where they are. So if I say that the goal for something is to improve the timeliness of change request processing from a project manager's viewpoint, I'm preparing a metric for the project manager, that's his viewpoint. His goal is to improve the issue of timeliness. So the purpose of what he wants is to improve things. The issue is timeliness of the object, which is change requests. So you organize things in such a syntax that it is very easy to define what their goals are. And then you can start asking questions based on the issues and the objects that he has. So if we're talking about improving change request processing, the question you have might be, well, what's the current change request processing speed? And then we want to gather a metric that says, well, what's the average cycle time today? And then another question might be, well, is that performance improving as the project goes on? And then you want to gather metrics that show the rate of change of it. But you're using this process to identify what metrics you need to improve what other people are doing. Project metrics have to assist in day-to-day project management, drive process improvement, or they are part of something that people need as part of what industry you're in. You know, as I mentioned, the guy from Medtronic, he probably had a library of data that he had to provide with every product release. Previous employer I was at, we had a tool that mined data out of HP Quality Center, which was our main, like our test case and our defect repository. And they wrote a tool that used an API in the HP Quality Center to pull all kinds of project metrics out about escaped defect analysis and rate of bug, rate of closure and average bug history length and all kinds of information that they kept collecting for years and years. And after several years, my boss's boss came to me and said, hey, can you put together some trend data for these various projects that we've had so we can see what our improvement has been over time. So we collected data for like 5 years, and then somebody decided that maybe they wanted to use it, which was a horrifying exercise in having my team go back and fill in the blanks and figure out what all these numbers really meant and try to answer his questions, in some cases 3 or 4 years after the fact. At best, the very best outcome of this was that it was an annoying project I had to fulfill a request from my boss's boss. But really just kind of what it felt like was a giant waste of everybody's time. And if it feels like you're wasting your time, then you probably are actually wasting time. So we've gone through our inception, we have all of our questions answered, we have some design for metrics, and now we've started working on our project, and we've started planning out the first sprint. Testers have to get involved right away. We don't want to wait until they have planned a user story for the sprint until that's the first time we see what that user story looks like. You want to read it, you want to review your acceptance criteria, digest it, start thinking about how to test it, and ask the right questions. Understand where are my data sources, what APIs do I interface with, when do I get software, all the kinds of things that you are going to care about for the duration of the project have to be asked right away. Once you're into a project and you're a couple months into code development, if you have to raise your hand and say, I don't know how to access the test environment, or I need an admin account, or how do I get to this database again so I can check my data, it's too late. That train's already moving down the track and you're running after the caboose trying to catch up. Ask the right questions right away and everything is going to get there. Figure out how to test before you figure out what to test. Part of the beauty of an Agile process is that you have all these small self-contained user stories that are focused on the user experience. They are business-oriented. They are not functional. So if you are sitting there in an Agile project and you're waiting for comprehensive requirements that say that the navigation panel for this screen is going to be in the upper left corner and there's going to be 5 options on it and it's going to be white text on a blue background, you're probably going to wait forever because the team's busy and designed to run lean and probably doesn't have time to write down all those details. Understand, do you need detailed requirements for your product because it adds value to the product or it makes it easier for you to write a test case around it? And if you're only asking because it makes it easier for you to fill in all of the details in the test case, then just let those details go and don't create work for somebody else. All that busy work kind of gets in the way of really understanding what the software is supposed to be, and you find yourself testing for the trees without seeing the forest of the product. This is another point, though, to also think about this snapshot in time. If there's decisions that were made about why something is being designed in Sprint 1 in a certain way, and if you know that you're not going to be working on the product forever, then maybe invest the time. That's fair. That's adding value by making it easier for people to come in the future to work on this. But don't do it just because you're creating work. Create less work for yourself and for everybody else. Test case creation. As you go through, you are writing test cases, whether they be manual or automated, for the user stories that you have. It is a necessary component of the process, and it is easily the greatest time waster if you're not doing it the right way. What's important as you write manual test cases is to have clear detail for future automation and have coverage to support each of these user stories. But don't get too much farther than that. Don't write test cases for code that isn't going to change again. And don't write test cases for every negative condition you can think of. You want those things to have a purpose. It is very easy to sit and keep adding detail and adding detail. As an example, a bunch of years ago, I worked at a defense contractor, and we were writing a test plan for a field demonstration and a technical concept verification We were taking a team of people out to the desert for a month to do things. I can't talk about what we were doing, but it involved a couple of different software components. And my job was to write the test plan for this field demonstration. And I looked at the personnel that I had, and I said, well, everybody understands how to use the system. I just need to guide them through the scenarios. And so I wrote up about a 15 or a 20-page document that listed all the things we had to do. And we went in to review it, and a manager from another team said, well, how are people going to know how to use the software to do this? And I said, well, it's the team of people that are going. They all know how to use the software. And he said, well, maybe what if we have a new person, or maybe if somebody gets sick, and maybe we need to add some more details. So I changed it from 20 pages to 50 pages to 100 pages, and I kept adding more and more detail to satisfy this voice that kept chirping up and saying, well, how is somebody going to know how to do A, B, or C? So we're basically out of time. We need to have this thing approved. It's now like a 200-page document. And we're in the final review meeting, and somebody pipes up and says, all the guys going to the field know how to use the system. Why is it so big? Why don't you just kind of tell them what to do and send them how to do it? And I'll leave it to everybody to know that it was the exact same guy that told me to add all the detail. So this was somebody who didn't mind creating work for somebody as long as it wasn't himself, and more importantly, didn't have the slightest idea about how to think about how to add the right level of detail and what to test. Don't be that guy. Please don't be that guy. Creating tests. It can be really fun to try to break software for the sake of testing it. I'll call it the testing party, or the negative condition party. Fun is not productive. I was in a recent user acceptance test session where we took a bunch of business users and we asked them right away. And we said, have you ever been involved in software testing before? Have you ever been involved in one of these type of sessions before? And they all said no. They weren't in IT. They didn't know anything about software test cycles. They didn't know anything about software testing. And we handed them some scripts and said, this is your UAT cycle. These are the things we want you to look for. And after a couple hours, they had spent some time walking through the scripts and looking for what they were looking for. And eventually, a bunch of them just started messing around and entering garbage data and trying to break the software just to see what happened. They were curious and they were having fun. And that's fine. But what it meant was that they were wasting time for what was a fairly well-controlled and created 3-day cycle. And they were already behind because they weren't being productive. They were just having fun. They were in there trying to figure out exactly what 12 steps I could do in a row and how to enter garbage data to try to break it. Well, that's cool, but if nobody's ever really going to do those things to try to break it, then you're just wasting time. Our job is to validate that the system performs in a robust manner, not to try to break it. They're two different things. Focus your negative conditions on how does the system behave if somebody makes a mistake, or what the data boundaries or the performance boundaries might be in a meaningful fashion, rather than trying to push it until it just breaks. How is somebody going to stress the user interface in a real way? People sometimes double tap on a monitor or on a touch device instead of triple tapping, or triple tapping instead of single tapping. All those sorts of things make sense. If you're just stressing the system by pushing the button over and over and over and over and over and over just to see what happens, you're probably not adding any value. And if you're writing test cases around that, you will always have this rabbit hole of, oh, I got another idea. Oh, and I thought of another way to break it. And oh, let me see what happens when I do this, and I see what happens when I do that. If you're sitting there brainstorming like that to figure out how to break the software, there's low risk that even the dumbest of stupid users is going to use the software in that way. And therefore, you're not adding any value when you test it that way. When you're in a project and you're in the middle of it and you're starting to get some bugs coming in addition to all the new work that people is working on, it's really important to understand how you're going to prioritize what you're working on. Are developers going to work on the new features or bug fixes? And when bug fixes come in, are you going to test the new features or are you going to test the bug fixes? Figure out what that process is as soon as you can If you wait until you have a backlog with a couple hundred bugs in it before you figure out how to prioritize what you're going to work on, you're probably too late. I know ahead of time, am I going to take 25% of my sprint to do bug fixes? Am I going to take 10%? Am I not going to do anything with any of the bugs until the end, and then I'm going to have a whole bug fix sprint? All of those are fine answers, but you got to think about it ahead of time. Another idea might be to say, we're going to have no backlog. The second a bug is found, we're going to triage it, and we're going to decide if we fix it. And if we decide we're going to fix it, then we do fix it and put it in the next build of the code. If we decide we're not going to fix it, then we never fix it. And we document that we saw this and we decided it's not a problem. And that documentation is really important as the future goes on, but it has to be documented because other people are going to find the same thing that you saw and have to know what to do with it. As you're running tests, you will have basis statistics that you gather as you're in the middle of these sprints leading towards the completion of a project. You have pass-fail counts. You have the number of tests remaining to be run. Do you need any more than that? Do you need to collect root cause analysis metadata for your failed tests? Yeah, it's a good idea. A lot of people don't do it. It's really smart for us to understand why tests fail. Your root cause analysis can be driven by these metrics that you are trying to gather as part of your GQM model. And root cause analysis can drive great process improvements, but you have to use it. RCA tells you why this test failed and what the underlying problem is. Things fail because of new tests, new issues, or known defects, or invalid test scenarios, wrong configurations. The underlying problem might be a bad build, or bad data, or bad code, but you have to figure out what those are. That's me, by the way, in the picture. That really handsome, young, well-dressed guy. Yeah, that's me. So you're welcome. As you're going through this root cause process, understand that it's not just you. As a tester, you don't have the visibility to say why something happened. You have to bring in business people and development people to analyze it, take a guess as to what the root cause is, fix it, and then update the root cause when we found out what the real problem was, and then validate it. You're bringing a bunch of people into the process. There's multiple people, multiple conversations. If you are not using this data as you go through it, you're not just wasting your time, you have now wasted multiple people's time. And remember, this whole idea of simplicity is about not wasting time. In your retrospectives for your project, every sprint typically has a retrospective in an Agile project. Bring this root cause information to you because this meeting is really important. It is the most underutilized retrospective or milestone in Agile, the sprint retrospective meeting. Most of the time, teams end up skipping it because nobody comes prepared and nothing ever happens. As a tester, you will be a rock star. If you show up and say, I've got all of these talking points based on our root cause analysis about why things are failing and what we can change to fix the problem. If you write 50 bugs in a sprint, and as it turns out 30 of them are because you have build problems, or because we have invalid tests that are written because we don't understand what the requirements are succinctly. If we're getting a bunch of bugs rejected is not a problem. We have to understand what that is. The time to bring that up is in sprint retrospective. And root cause analysis, all these metrics provide the underlying ammunition you need to support your claim that this is a problem and here's what we can do to fix it. How do you prevent this stuff from happening again? That's the whole point of retrospective. This is where you can provide value. If you're a tester on an Agile process, this is one of the best ways for you to provide value to the team. When you're in your testing tool and you're keeping track of defects, they all come with these various states. One of the simplest bug models is the one that's up here. It's one of the defaults from Microsoft Team Foundation server that says what's new, hasn't been worked on yet. Assigned meaning, okay, I agree that it's a valid bug and that it's going to be worked on in the sprint. Committed, meaning that somebody's fixed it, developed it, and checked the code in. Done, meaning that the fix has been verified and it's out in the world and it's not a problem anymore. 4 simple states. You can have more. Think about what you need and why you need to have more. Again, tie it back to your GQM model. If there's defect metrics that you need, design your state model to answer those questions, but don't just have information based for the sake of hoarding information. Otherwise, you're a hoarder. You're that guy. Don't be that guy. Otherwise, you're just gathering this information without learning from it and improving from it. This maze of spaghetti is a real bug model from a real project with these 7 states, and each of these states has various sub-reasons behind them, and each of these transitions from one state to another has all of these other reasons and pieces of data that are associated with it. You look at this, and you have to ask yourself, if there's a real problem in here, if there's a bottleneck that is causing us to have issues with our projects, how do I look at this one area within this mess and say, I can fix this by doing something? Which is the whole point of gathering all these metrics. If you can't use it to improve, then you've got a big problem. By the way, the team, when I came in to look at this, the team of people knew that what they were doing had gotten out of control and was wrong. They just didn't quite have a feeling for how bad it was and why they needed to fix it until I went in and looked at it and wrote down all this stuff and showed this picture. So be thinking about it all the way. This is a good area for continuous improvement. Don't hoard this information. I'll say it again. Each of these data points lead to decisions and, more importantly, arguments and dissents. And the more stuff you have, like any good hoarder, the more you tend to collect and the more you want to add. So if I go back to that other picture and say there's all these different data points, and let's say we have to change some piece of metadata 10 times for each bug as it goes from new all the way through to being done. And we have to have a minute conversation about each one of them, or have a minute to make a decision about, well, is this ready to move from one state to another, and what reason should I select, and why am I doing this? And let's say we have 500 bugs on our project, which is probably reasonable for any project that takes over a period of months. You're going to have over 80 man-hours. That's 2 weeks of somebody's time that does nothing but manage all of this stuff through the process. Is that really a valuable use of somebody's time? I would definitely argue that it's not. Everybody can be providing better feedback than just saying this is what's going on. Every defect model tends to have another state besides the 4 that I listed: the new, assigned, committed, and done. Almost every defect model also has something that says that this is removed. When I enter a bug and it's a duplicate of one that I already have, it gets removed because it's a duplicate. If I write a bug that's not really an issue, it gets removed. If I write a bug for something that's still pending software, it gets removed. If I write a duplicate, it means that we need to improve how we use the tool so that we search for the bugs that are already out there and make sure that we don't enter one that already exists. If we write a bug that's not an issue, it means we don't understand the requirements well enough. If we write a bug for a pending feature, it means that as testers we need to understand the planning of the software and what is to be coming in a future sprint, so we're not looking for stuff that doesn't exist yet. Each one of these is an area of potentially great improvement for our projects and for how we do our jobs. But if we're not collecting this data and then using it, if we're just saying tag it as a duplicate and then throw it in the remove bucket and never think about it again, you're not using your data to improve. And if you're not using it to improve, you probably shouldn't be sweating it too much at all about what you're collecting. So I'll leave you with a checklist. All of these are things that were brought up in the last 40 minutes or so as I've been speaking, and I thank you again for everybody's patience and attendance. If you leave here with nothing else, take this idea with you, that you're going to have a checklist of all of these things that are areas for you to improve on, making sure that your testers are involved from the inception of a project, determining what are your necessary deliverables, getting involved as soon as possible to evaluate acceptance criteria, trying not to get hung up in perfect requirements, how to design tests for manual automation and not test for bugs. All of these different things will make your projects better, especially for a fast-paced Agile team. Pick one of these things and just try it in small doses. My hero, Matt Paxton, that you saw in the beginning, talks about if you've got an area of clutter or a really messy part of your house, just do like a 10-minute sweep every day. Or just go stand in a messy area and pick up one thing at a time and say, what do I do with this? Do I know where it goes? Cool. Take it and put it where it goes. If I don't know where it goes, ask yourself if I need it. If you don't need it, throw it away. What I'm suggesting here is not trying to fix your entire process for testing all at once, but pick one little area and tie it together, fix it one small piece at a time. Take a few minutes every day and think about your process, and eventually you'll have a much cleaner process. Keep cleaning. Always be looking to improve. If you only remember one thing from what you got out of this, if you can't tell me why you're doing something and how it helps your team, then please stop doing it. You are wasting your time. And all of our time is far too valuable to be doing that. So it's important to understand that we're not just waiting at the end of a cycle. We're not the last step in software development. It is our responsibility to make sure that we add value. So please be efficient and be very important to your projects. And with that, I thank you, and we'll turn it back over to Nancy to conclude what we're doing here.
Okay.
Even if it's just hanging up the phone.
Okay, thank you very much, Paul, for that great presentation. We do have